This video is going to talk to you about standard form, which is a way that we can write really big and really small numbers to make them easier for us to understand. It's often used by scientists and in applied mathematics because that's when we often have some of the biggest numbers needed. If you think about the number of bacteria in a small petri dish, there'll be millions and millions. And obviously it's very, very difficult to deal with really, really large numbers without being able to get into a bit of a pickle. So really big numbers, really small numbers. We're going to start looking at really big numbers. So if I had, for example, 1 million. Now, most of us are quite happy that 1 million has 6 zeros. It's 1 times 10 times 10 times 10 times 10 times 10 times 10. It's 1 times 10 6 times. It's 1 times 10, 10, 3, 4, 5, 6. Okay? And it's not too bad, it's not too big a number that we can't understand it. When we see it, we might be very quickly in our heads counting the number of zeros, but we can see it, we can work out that that's what it means. But this is what it breaks down as. And we could write that in a different way as well. We could also write that as 1 times 10 to the power of 6, couldn't we? And then if we'd written it like that, because we've got 10 multiplications of 6, multiplying by 10, multiplications of 10, multiplying by 10 6 times is the same as multiplying by 10 to the power of 6. This number is that written in standard form. Standard form is very specific. It's standard, that's the idea. It's the same for everybody all over the world. Standard meaning exactly the same for everyone. So it's standard form, it's written in the same way. And a standard form number always has just one number, one digit, before a decimal point. In this case, that would be 1.0, but it's only ever going to have one digit. So that's always going to be between 1 and 9. We're never going to have a 0 and we're never going to have a 10. It's always going to be between 1 and 9. So if we had, for example, then 3,500,000, so this time we're only going to have 5 zeros because we have the 3,500,000, we would write that as 3.5, just one digit, the 3, before the decimal point, then our 0.5, and then we'd put it times 10 and we'd have to work out to the power what? Well, what would I multiply 3.5 by to get 3.5 million, 3,500,000? I'd multiply by 10, 1, 2, 3, 4, 5, 6 times. The 3 times 10 to the power 6 would give me 3 million, 3,500,000. So that would be this number written in standard form. Let's go for a really big one. Let's have 5, 6, 9, 4, then 1, 2, 3, 4, 5, 6, 7, 8 zeros. I'm not even going to attempt to name it. It's a really, really big number. 5, 6, 9, 4, and then 1, 2, 3, 4, 5, 6, 7, 8 zeros. So we know that we must have just one digit before our decimal point. So we're going to put the 5, then we put all the other numbers afterwards. 6, 9, 4, all the actual digits afterwards. We're not going to bother about the zeros because they just can be lost in the decimal places. Then we know we have to multiply it by 10 to a power. We'll put on a note about that in a moment. And we're going to have it times 10 to the power of what? So how many times do we have to multiply the 5 to get it to this size number? So we've put our decimal point just there in our answer. So we're going to have times 10 once, twice, 3 times, 4, 5, 6, 7, 8, 9, 10, 11 times. So that would be our number in standard form. Okay, let's finish these notes. So it always has just one digit before a decimal point, and it always is multiplied I can't spell, by a power of 10. Let me rub these numbers off underneath to help you make your notes so that you can read what I've written nice and clearly. And that's the two basic principles of standard form. If we have very, very small numbers, that sometimes feels a little bit different. So we'll just do a couple of examples with some very small numbers. For example, let's imagine I've got 0.0000438. Okay, so I've not got anything in my tenths, hundredths, thousandths, 10,000ths column. My first real number, my first actual digit is in my 100,000ths column. So if I wanted to put this into standard form, I would still follow the same rules. It always has one digit before the decimal point, from 1 to 9. So I'm going to put my 4, my first non-zero number, as my first digit, 4.38. Now this time when I multiply it by 10, what I'm actually doing is sort of dividing it by 10 lots of times. If you know your powers and you know your indices well, then hopefully you'll already have come across the notation of a negative power. If not, this is the first time you're going to see it, but don't panic. So if we're going to have our decimal point coming in here now, we've divided by 10 1, 2, 3, 4, 5 times. And we use a minus, a negative power, to show that. So it would be 4.38 times 10 to the minus 5. And that negative power shows us that our number is actually really, really small and not really, really big. Over here we had to a positive power. Over here we have to a negative power. Big numbers have positive powers, small numbers have negative powers. Let's do one more like this as another practice. 0.000372446, and that again, one number before the decimal point, and then all the others go afterwards. And then what have we had to divide by 10? How many times have we had to divide by 10? To get to here, we'd divide by 10, 1, 2, 3, 4 times. Because it's a small number, or because we've divided by 10, it's a negative power. So it's 3.7246 times 10 to the negative 4.